Okay. I gave it to you last. So where did you take the notes on? Okay. What day were you absent? So did you get on Google Classroom and print it off? Why am I wasting my time putting stuff on Google Classroom if you're not going to look at it? Or did you get the notes down? Did you get the notes down on Google Classroom for 2-1 and 2-2? Yeah. On a separate sheet of paper? No. Did you not write them down?
For 1 and 2.
For 2-1 and 2-2. The notes from Google Classroom. Okay, so let's go ahead and look at 2-1 and 2 or 2-3. We did 2-1 and 2-2 Monday. Let me grab the lights for me. Thank you. Okay, so we are continuing with equations. We are looking at dealing with the same sort of idea, same basic idea. We are solving equations. So we are trying to figure out what number does the variable represent in the equation. So what number, if I plug in where the variable is, gives me the left side and the right side that are equal. Because that's what an equation means. That's what an equal sign means. So our goal is the same, but we're going to have more steps to it. It's not just going to be as simple as subtracting 4 from both sides or dividing by 3 from both sides. We're going to have two different things that we need to do to get the variable by itself. So here are some steps. Same goals. Goal is to get the variable by itself. Maybe. Goal is to get the variable by itself. So same goal as with one-step equations. Now here's the key with two-step equations. You're going to start with the number. You're going to start with the farthest number, or the number that is furthest away from the variable. So you're going to start with the outside. You can put outside here if you want to. You're going to start with the outside number, or the number that is furthest away from the variable. Now, as we look at some examples, I'm going to talk how you're going to figure out which is the outside. You're going to kind of think about, okay, if I would plug a variable in, which would be the operation I would do last? It will make more sense once we look at an example. So start with the outside number, or the number that is furthest away from the variable, and use the inverse operation to get rid of it, just like we did on the ones Monday. No, Tuesday. Okay? Now, the next step is we are going to use inverse operations. Guys, Austin, all of you guys, cut it out. So, use the inverse operation to get rid of the number that is closest to the variable. So we're doing the outside first, and then we look at the number that is closest to the variable. So start on your outside, and then work your way in. And you do the same thing we did on Tuesday. You're going to use the inverse operations, or the opposite operations. So some of you guys have a good idea how to do this, but we're just kind of looking at multiple step equations, two-step equations. Okay, look at example 1. We're going to solve. So you see the keyword solve. That means get the variable by itself. And then it's going to it tells you to check your solution. So we're going to check a couple of these real quick, just so you get practice checking these. You can always check equations. Any equation, you can always check it. So I want to solve this equation. Now, as I look at this equation, my goal is to get a by itself. My goal is to get the variable by itself. Now, as I look at doing that, on the same side with the a, I have the 2 and the -6. You need to get rid of the farthest away, or the outside number first. Now, when I mean the number furthest away, I mean if I would plug a number in for a, what would I do second? So if I would plug a number in for a, I would multiply by 2 first, and then do what? Subtract the 6. So whatever thing you would do second, so if I would plug a number in for a, you would multiply by 2 and then subtract the 6. This is the furthest away. The negative 6 is the furthest away. So whatever you would do second, if you plugged a number in, is the number that's furthest away. That's another way to think about it. So we're going to use inverse operations. What's the opposite of a negative 6? So we're going to add 6 to both sides. Okay, so on the left side, negative 6 plus 6 cancel. I have 2a equals 4 plus 6, 10. And now it looks like an equation we did yesterday, or Tuesday. I need to get a. It's not solved yet because a is not by itself. How do I get rid of the 2? Yep, divide by 2. 2 times a, the inverse is divide by 2. 10 divided by 2 is 5. If you struggle with dividing numbers or multiplying numbers, use a calculator. Do not let that mess you up because you struggle with multiplying or adding numbers. Okay. Now let's go ahead and check it real quick. If I am checking it, let's check it over here to the side. So, you can check an equation pretty simple. You just plug in your answer for the variable. So if I said a was 5, we're going to plug that in. So 2 times 5 minus 6 has to equal 4 because it's an equation. So the left side and the right side have to be the same. 2 times 5, 10, minus 6 is 4. 4 equals 4, and that is good. Yes. Okay. Those are not mine. I'm not sure who those would be. Sorry. Okay. Yep. Okay. So, any questions on that one?
No.
Okay. Good. Okay, let's look at a couple more examples. Okay, let's look at B. So, if I want to solve this equation, I need to get the variable by itself. I need to get n alone. I notice on the same side with the n, I have the 1 and the negative 2. So I need to get rid of the number first that is furthest away from the n. Which number is furthest away from the n?
That would be negative 2.
It'd be negative 2. Now, another way to think about this. If I would plug a number in for n, what would I do first? If I would plug 2 in for n, what would I do first? Add the 1 and then divide by negative 2. So whatever thing you would do second is the one you get rid of first. So I have this dividing by negative 2. How do I get rid of dividing by negative 2? What is the inverse of dividing by negative 2? Multiply by negative 2. Remember, multiplying by a whole number, you can put it over 1. So it's the same as multiplying by negative 2 over 1. You have to do it both sides to keep it equal, because it's a equation, so we have to keep both sides equal. Now if I multiply, yes?
Why'd you scribble out B?
I just put a dot for multiplication. Yeah, I just covered it up. So, as I look at multiplying by negative 2, what happens to my negative 2 on the left side? Cancels, because I have a negative 2 on the top and bottom. So I have n plus 1 equals 15 times negative 2. Negative 30. Okay, now I have a one-step equation, so now I subtract 1 from both sides to get n by itself. Negative 30 minus 1, negative 31.
I'm smart.
Okay, now, guys. So, if I want to check this, we can just plug it back in to check it. So if I plug it in, we're going to plug negative 31 in where n is. So negative 31 plus 1 divided by negative 2 should give me 15. Let's check that. What's negative 31 plus 1?
30.
Negative 30 divided by negative 2.
Positive 15.
Positive 15. So that you can always check any equation by plugging it back in and making sure both sides are equal. Okay, any questions on that? Okay, let's look at C, and then we're going to look at a couple story problems. If I look at C, my variable is Q. I want to get Q by itself. Do I get rid of the 2 or the 11 first? 11. How do I get rid of the 11? Use the inverse. Subtract 11. So 11's cancel on the left side. I have 2Q equals, what's 3 minus 11? Negative 8. It's the same idea we did Tuesday, except you have to do one more step. Now, how do I get Q by itself? Divide by 2. Divide by 2. Q equals negative 4. Negative 8 divided by 2 is negative 4. Now, guys, I'm not done. Stop with the talking. The second I stop talking, it doesn't mean you get it. I'm still finishing it. Okay, so if I check this, so if the directions say check, then I want you to check it. If they don't, you don't need to worry about it. So plug in negative 4. 2 times negative 4 plus 11, and that has to equal 3. What is 2 times negative 4? Negative 8 plus the 11. Does that equal 3? Yes. So that's all. You don't have to do much work when you check it. Just plug it in and see if the left side comes out to be the right side. Okay, any questions on this? Okay, a couple more. Example 2. So, story problem. We talked about story problems earlier this week. So we want to read it, we want to look for what they're asking for, and that's going to be my variable. So Susan had a $10 coupon for the purchase of any item. She bought a coat that was on sale for half of its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price of the coat? Write an equation for the problem, then solve the equation. Story problems. What do I always tell you to do first?
Underline the important stuff.
No.
What they're asking.
Look for what they're asking for. As I read this, they're asking for what? Original price of the coat. That is going to be my variable. So P is going to be original price. So P is the original price of the coat. Whatever they're asking for is almost always going to be your variable. P is the original price of the coat. Now go back through, and we want to try to set up an equation by reading what they tell me. Susan had a $10 coupon for the purchase of any item. She bought a coat that was on sale for half of its original price. After using the coupon, Susan paid $125 for the coat. What was the original price? Okay, help me set up an equation. Look for keywords that tell you operations. So everyone should be looking over this. If you're not doing it, it's not going to help you learn it. If you just wait for me to tell you, it's not going to help you learn it. So look at it, read it. Logan, keep your head up, please.
Original price.
We're looking for things that will help me create an equation. So we're looking for keywords that are going to tell me operations.
Half.
Add, subtract, multiply, divide. Half.
$10 coupon, what should we subtract?
Okay. We have a $10 coupon, so a coupon takes money away from the price, so we're going to be subtracting 10 somewhere. Okay, keep reading on the half part. Half
Of its original price. So
Okay.
divide.
of means what? So half of the original price is going to be represented as what? Okay. 1/2 P. Half of the original price is 1/2 P. 1/2, Ethan, please. 1/2 times P is going to be 1/2 of the original price, because P is the original price. So she is going somewhere. She's buying a coat. It's half off the original price. And then what else do I need to do? Do what? She also has a coupon. Subtract 10. And that equals what? 125. Think about it. If I go in and buy a coat, I look at the price tag, that's the original price. The clearance is half off, so they're going to take half off of it. And then I have a $10 coupon, so they're going to subtract 10. And then the price I paid for it was 125, so that's equal to 125. Now, I want to know P. I want to solve this for P. So inverse operations. I do what first? Get rid of the half or the negative 10? So we are going to do what? Add 10. Add 10 to both sides. So 1/2 P equals 135. Okay, 1/2 P equals 135. How can I get rid of a half?
Divide it.
Could divide by a half. What? How could I rewrite this so I don't have to divide by a fraction? Yeah. No? No. We talked about this on Tuesday. How could I rewrite 1/2 times P so I don't have to deal with the fraction? So I don't have to divide by a fraction. How can I rewrite 1/2 P? No? No? Okay, go back and look at your notes. I'm not going to answer it for you. We talked about it. No? How can I rewrite a fraction times a variable so I don't have to divide by the fraction? I showed you 2 ways to do a problem. One of the examples Tuesday. Okay, keep looking. I showed you 2 ways to do a problem on Tuesday. One way dividing by a fraction, and the other way was kind of a shortcut, so you didn't have to divide by a fraction. Where can I put the variable so I don't have to divide by the fraction?
Didn't you say you just put this in?
No?
Oh, good. I don't know.
Look at your notes Tuesday.
I'm looking at my notes.
Okay? Look at the example where I did two ways to solve it. I showed you 2 ways to solve one example. One way was dividing by a fraction. I said if you don't want to divide by a fraction, you can use this shortcut instead. If I have a fraction times a variable.
Multiply it by opposites.
No? That's not what we did. So you're probably not going to find the answer if you're not actually looking at the notes we took Tuesday. Just a thought. Look at the notes. We took 2. I showed you 2 ways to do notes.
There's nothing there. I looked through all of them.
Okay, well, it's actually right here because these are the ones we took. Example 3. I showed you 2 ways to do example 3.
I solved it.
One way was dividing by the fraction, 3/5. The other way, I showed you a different way you could do it. If I don't want to divide by a fraction, how can I rewrite it so I don't have to divide by a fraction?
But the variable with the top number.
Yes, put the variable with the top number. Do you need me? Put the variable with the top number. So, how could I rewrite this 1/2 P to put a variable with the top number? I don't want those. Too bad. Are you calling me fat?
No, he thinks they stink, and I told him that you've been eating.
What? Yeah, I've had like 2. Okay, so where do I put my variable at? With the 1. So this becomes P divided by 2 equals 135. You could divide by a half, or if you have a fraction times the variable can just go on top. That's the shortcut. So now we don't have to worry about dividing by the fraction. How do I get rid of the 2 to get P by itself? Multiply both sides by 2.
And then it's 270.
So, P equals 135 times 2. 270. Okay, now, if there's another way you did it, I don't care. That's fine. Use whatever way you did. I'm just trying to show you different ways to get to the same answer. Now, why does 270 make sense? Why does 270 make sense in context of the problem?
Because that's the original price of the coat.
Okay, why does that make sense? That is the original price of the coat.
You add 125 plus 125 and just put the 10 back in there.
Okay, you could think about it that way, but even easier than that. What was the sell price she paid for it?
Half of it.
125. So the original price is probably going to be more than the sale price. Otherwise, it's a crappy sale. So your original price should be more expensive than the clearance price that she paid for it, which it is. Okay? Any questions on that one? John, don't start on the homework. We're working on the notes now. I give you plenty of time for homework. Close your book, please. Okay, let's look at example 3a. We want to find 3 consecutive integers with a sum of 21. Now, these are tricky, but you guys can do them, I promise. Okay, David asked, what does consecutive mean?
Multiple.
Consecutive.
Numbers that will all equal to 20.
I want something consecutive. If I need something that is in consecutive order. Okay, look it up on Google. Get your device open and Google search it. Consecutive. Okay, that's not my issue.
Not mine either.
Really? Okay, well, I guess nothing is your issue then. Okay, consecutive. Look up what consecutive means.
My device is completely dead.
Not my issue again.
Huh?
Not my issue.
Again.
You're expected to come to school with a charge.
Well, I did it.
Okay, that's fine. I'm just saying.
No, I don't even want to get on there.
Okay, consecutive.
Hey.
Google search, meaning definition of consecutive, or just type in consecutive. That works too.
Okay, Google.
Okay, someone tell me consecutive.
I said multiple, is that right? Like
No?
more than one?
No? Definition of consecutive. Okay guys, listen up. Justice, what do you find?
Following continuously.
Okay, his definition he found was following continuously. Okay, let's find another definition, consecutive. Yes. Okay, continuous. So following continuously. Give me another word for consecutive. Following in order. So what would be consecutive numbers?
Same number.
No. If it's following in order, what would be consecutive numbers? Okay, if it is following in order, consecutive numbers are one right after another. So when I say consecutive numbers, 3, 4, 5 would be consecutive numbers. 7, 8, 9 would be consecutive numbers. 10, 11, 12 would be consecutive numbers. They are continuing in order. So 1, 2, 3 are consecutive numbers. 5, 6, 7 are consecutive numbers. They are numbers that go in order. Okay, so close your devices. Consecutive means in order. Okay, one after another one. Now, listen up. Or keep talking, because that's great too. So, consecutive numbers is in order. 4, 5, 6, 7, 8, 9, 10, 11, 12. I want 3 consecutive integers. Integer means what? We talked about it yesterday. Integer.
Numbers.
No, more specific.
Not
No.
a fraction or decimal.
Not a fraction or decimal. Actually, we talked about when we did bingo 2 days ago. Integer. We're going to have no fraction or decimal part. So if I want 3 consecutive integers, I want numbers in order that do not have decimals or fractions. 4, 5, 6, 7, 8, 9, 10, 11, 12. I want 3 consecutive integers with a sum of 21. Now, some of these you will be able to think about, but I want you to set up your equation. Guys, Ethan, please.
I didn't say nothing.
Okay. So, 3 consecutive integers with a sum of 21. So, what am I looking for in this? This is a story problem. I always want you to look for what you're looking for. What are you looking for in this problem?
Numbers that can equal 21.
Numbers, consecutive integers with a sum of 21. So, my variables are going to represent integers. That's what I'm looking for. So, x is going to be my first integer. Okay? Even though it doesn't say what necessarily, it doesn't use words like what or how many, it says find. I want to find 3 consecutive integers. So my variable is going to be x. That will represent the first integer. Now, if I want to represent the second consecutive integer, what will I do to represent the next number that comes after x? No. Because I don't want multiple variables. I want the same variable because it'll make it easier to solve. If I start with 1, how do I get the next consecutive number? Add what? How do I go from 1 to 2?
You
You add 1. Don't make it harder than it is. So if x is my first integer, my second consecutive integer will be x plus 1. Because to get to the next number, you add 1. Now I know this is tricky, but we're just going from 2 to 3, or from 4 to 5. We're adding 1 to get to the next one.
How do you get it?
Now, I need 3 consecutive integers. So how do I get to the third consecutive integer using x? Because I want to use x, so I can solve for x.
X plus 1.
No. Okay, x plus 1, which is x plus 2. That is the third integer. So, we use variables. We are looking for integers, so we use variables to represent them, and they are consecutive. So if I start with my first one, I add 1 to get to the second one, I add 2 to get to the third consecutive. If I start with 4, I add 1 to get to 5, 4 plus 2 is 6. Okay? Any questions on the setup?
No.
Now, these integers have a sum of 21. So how do I represent these integers having a sum of 21? Sum means what?
Addition.
Addition. So how do I represent these integers having a sum of 21? Okay, so what do I add together?
2 plus 3.
No, because those aren't the numbers I'm working with. What represents my integers?
7 plus 9.
X plus, I'm adding the sum of these integers is 21.
9.
First integer is x. What was the second integer?
Plus 1.
So x plus 1 plus x plus 2. The sum of those three is, that's an x there. The sum of those three is equal to 21. So we take those 3 integers, x is the first one, x plus 1 is the second, x plus 2 is the third. We add them, the sum is 21. Any questions on that?
No, sir.
Now, on the left side, we need to simplify like we did a couple weeks ago. So how can I simplify or combine like terms on the left side? How can I combine like terms on the left side?
Add all the x's.
Okay, so let's add all the x's. X plus x plus x. 3x. Plus what?
Plus 3.
3 equals 21.
Subtract 3 and then.
Just a second. Okay, so left side, we're going to combine like terms. 3x plus 3. Sheldon, please. Talking. 3x plus 3 equals 21. Now, if I need to solve this equation, we're going to start with the number that is furthest away. So we're going to start with this positive 3 by subtracting 3. That's furthest away from the variable. I'm left with 3x, 21 minus 3, 18. Divide by 3, x equals 6. Have I answered the question?
No. Yeah.
No. I'm looking for 3 consecutive integers. Have I found the 3 consecutive integers?
No.
Okay, I found x. X represents what?
6.
6, the first integer. How do I get to the second integer?
1.
Do what? Add 1. So 6 plus 1 is?
7.
How do I get to the third integer?
2.
Add 2. 6 plus 2?
9.
8. It's x plus 2. So 6 plus 2. No, I said x plus 2.
Oh.
6, 7, 8. Now think about it. If you add these, 6 plus 7 plus 8, they will give you 21. Okay, any questions on that one? Okay, let's look at the next one. One more example. We don't take notes every day, so you'll be fine. Okay, so if I look at B, find 3 consecutive odd integers with a sum of 57. What's different about this one? Guys, stop with the chatter, please. I ask you a question. That doesn't mean start talking with your neighbor. Let's think about it. What's the difference between this one and the one before it?
They want
They want odd integers. So let's think about it. I still want 3. So let's start. X is still going to be my first integer.
Plus 1.
Now, I want odd integers. So if x is my first integer, let's start with 3. 3 is an odd number. How do I go from 3 to my next consecutive odd integer? What's the next consecutive odd integer? 5. So how do I go from 3 to 5?
Add 2.
Add 2. So it's going to be x plus 2. That's the second odd, I can put odd, I guess, odd integer. So if I go from 3, I add 2 to get 5. And then what do I add to 3 to get the next odd integer? Not to 3. 4. So x plus 4 is the third odd integer. Now, it's the same idea, but since we're dealing with odd, we need to skip the ones in the middle. So instead of x plus 1, x plus 2, we start with odd, so we need to add 2 to get to the next odd. And then we need to add 4 from the first one to get to the next one. Does that make sense? This is done the same way with even. If it asks for even, you do it the same way. X plus 2, x plus 4. So even or odd, you use x, x plus 2, x plus 4 instead of x, x plus 1, x plus 2. Okay, now, 3 consecutive odd integers with a sum of 57. How do I set up my equation?
Wait.
3 consecutive odd integers with a sum of 57.
I don't know.
Okay, you're using homework time by not answering this question. because you're having side conversations. Okay, 3 consecutive odd integers with a sum of 57. How do I set up my equation? Okay, x plus 2 plus x plus 4. That is representing adding my 3 odd integers. X is the first one, plus x plus 2 is the second odd, plus x plus 4 is the third odd. So I'm adding my 3 odd integers, and I need to get a sum of 57. So that is going to equal 57. Okay, before I can try to move things around, we need to simplify. What's the left side simplify down to? 3x plus 6. X plus x plus x. 3x. 2 plus 4 is 6. 3x plus 6 equals 57. How do I solve the next one? Subtract 6. Take care of the inverse from the outside. The outside is 6, so we're going to subtract 6. 3x equals 51. Austin, write this down, please. Okay, how do I get x by itself? Divide by 3. X equals 17. Now, have I answered the question? No. Okay, I want the 3 odd, consecutive odd integers. So 17 plus 2 is?
19.
17 plus 4 is? 17 plus 4 is 21. Okay. Any questions on that? Okay. Homework is on the backboard. Okay, it's page 94, 11 through 29. Page 94, 11 through 29.